differential axial shell deflection be measured? Consider this figure, shows the ovality measurement raw data curves of a shell, which does not sit straight within its supporting tire. Ovality measurements typically consist of 3 measurements on the shell uphill of the tire, and 3 downhill. These are noted as A, B, and C uphill, and as A, B, and C downhill respectively. The data is graphed in the linear form as opposed to the more common radial form so that the differences in the curves are more easily seen. In this format, the size of the gap at the top of the rotary kiln is characterized by the deepness of the large dip in the curve, as noted in this figure. The larger the gap, the deeper the dip. We follow together, can differential axial shell deflection be measured? It is significant to observe therefore, that the 3 curves downhill of the shell, are consistently less deep than the 3 curves